Hello everyone, it's November the 13th. All right, daily temperaturas. Come on. Load. All right. Oh, it's a new one. Never done this before. Nice. Given an array of integers represents the daily temperature. Return an array such that answer I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which there is possible, keep answer equals to 0. Okay, so the number of days you have to wait after, so at this day, I say number of days I have to wait is 1 because 74, right? And 74 is 1. But 75, I have to wait 1, 2, 3, 4 days. 71, I have to wait 2 days. 69 is 1 day. 72 is 1 day. 76 is 0 days. And 70. So the last one is always 0. So that should be 1110, right? There's a 110. Okay? That screams dynamic programming at me. So we're gonna go try dynamic programming. See if it works. So we have 73, 74, 75, 71, 69, 72, 76, and 73. All right. How do we approach this? So at 73, I want to know how many days. So I want to know the day that has a higher temperature than me. The first day that has higher temperature than me. So I look for the next one. I look for 74. And if 74 is already larger than me, then I am 1. If 74 is not larger than me, which means 74 is smaller than me, then I need to find the first day that's larger than that value, right? Okay, so it's like kind of jumping, right? So if 74 is larger than me, this one is 1, and I don't have to consider this at all. If this position is lower than 73, then I need to find the first temperature is higher than this, right? And if that one is also higher than 73, then that's the value. If not, then 73 will be jump onto that one. Okay, let's go backwards. I feel like backwards would be easier. This value is 0. So this value, right, I want to see if this is larger than him. If it is, that will be 1. If it is not, then if it is smaller than it, and I will look at which one, and if it's a 0, then I'm a 0 as well. If it has a value, then I need to know the position, right? I need to know the position of the value. So it's a 0, then we can just record 0 and a -1, right? So we have 2 arrays, right? Let's see, we have 2 arrays. One is the result, the other is the actual position. So 76 is going to be 0. Oh, right. Yes, 76 will be 0. Now 72. So I look 76. 76 is larger than me, then I recorded 1 and recorded the position. It's going to be 0, 1, 2, 3, 4, 5, 6. So position is 6. 69, 1, oh, it's larger than me, so the 1, position is 5. 71, I look at 69, is smaller than me, so I look at the position. Position is 5, so look at 5. 5 is, look at 5. 5 is larger than me, so I'm going to be this value plus 1, so that's going to be 2. 71 is going to be 2. And position is going to be 5. 75, again, I look at 71. No good, I look at 5. 5 is 72, no good. 72, we'll look at 6. Okay, 76, that's good. So the number is going to be, so 70, this one needed 2. So I have a plus 2. And this one plus 1, so plus 3, so plus 1 be plus 4, so 75 is going to be 4, and the position is going to be 6, so this one, right, 6. 74, that's 1, so this one's going to be position 2, and 73 is going to be 1, position is 1. So that is the result, 1142, 1100. Okay, so I think we got it, unless there is some weird edge cases. But overall, what did you do, man? What did you do? I got it wrong. It's not 1, it's 13. Alright. There we go. Alright, so I'm going to go for, so I have 2 arrays, right? So one is result array, it's going to be 0. Oh, let's go n, land temperatures. This one times n. And we need another one, we'll call it POS, pause, standing for position, -1 times n. Alright, so for I in range n minus 1, -1, -1. Alright. Oh, actually, no. You can go n minus 2, because the last value is going to be 0 no matter what. So it's here. I'm going to say while temp is equal to 0, while temp equals 0, j equals to I plus 1. So while temperatures j is smaller or equal to temperatures I, then temp plus equal to position I, no, position j, right? And then, no, not position j, result j, and j equals to position I. Right, so I'm going to go back again until one of them is larger. Then we come out, then we say res I equals temp plus 1, which actually I can just initiate to 1, right? Oh, hold on. What if I don't find anything? Right here, right? If I don't find anything. Let me think. So it could be that all of the temperature J is small, right? All of them are small. So while J is larger or equal to 0, for the last one, so something that it will be -1, so it's larger than 0, and this, there you go. When we get out, I'm going to check on J, right? This equals to this if J is larger or equal to 0, otherwise 0, right? And then position I equal to J. So we run this, once we're done, we return res. Alright. Let's see how this one goes. Alright, first we have 3 test cases. Very nice. And these are like trivial test cases. I'm gonna have a edge case like 1, right? 1 value could be the edge case. So what I'm gonna do is just do 1, or maybe just do 50, more like temperature. This one I'm gonna return 0, right? And I just think of another one, 50, 50, and 50. It's going to be 0, 0, 0. Oh. Okay. Daily temperatures. Go. Oh, the first one is not correct. These are triple cases. All right. What happened? 0, 0, 1, 1. The 2 is not correct. Huh. How? Temp start with a 0. And this is a 1. 69 is also correct. Yeah, of course 69 is correct. 71. So 71, okay, let's go to logic again. 71, right? I'm at this position. J starts at here. J logically is 0 and temperature J is smaller than temperature I. Then temp plus equals 2 rest J. That should be 1, right? So temp right now is 1 because this one is 1. And then J equals to position. Position I. That's not position I. That's position J. There we go. That was the error. Okay. Go for it. Pending. Judging. Passed. 498. Getting closer and closer to that magical 500. I'm going to write a post when I get to 500. Take a screenshot and get it. Oh, that's going to be Monday. That is going to be Monday. All right. Wow, this one is slow. I thought I'd get, oh, it's not slow. It's like, this is average, right? This is average. This is average level. Oh, has a solution. I didn't see that. All right, LeetCode 739, right? So DP, going from back to front. Oh, this is this, hold on, let me, because we have this while loop, right? And this is if this is smaller, if it's smaller, then we're just going to, no, it's at most, because if everything is smaller, and those will just be -1, right? Those position would just be -1, so that should be ON. I'll call that ON, right? I'll call that ON because I jump this J. The J jumps, which means that something is bigger, so we jump. And if it's still smaller than jump, so the worst case scenario will be at a position that's really high, and then everybody else is like something really high, and everything else is from low to high. So I check the first one, no go, so we just go jump one at a time, right? But in that case, when we do this, that's ON, and the result, this can be, and the next one, if it's larger, then I check this, then it will jump immediately. No, I think it should be on average is ON. Right? If it's larger, if it's much larger, then we'll see this one is -1. It's smaller than this, and J equals -1, then we stop. Yeah, I think this is O1. Going from back to front, we record 2 arrays. One is for answer, recording the number of days to wait until encountering a higher temp in the future. and the other is the corresponding index of that higher temp day. So for any given day, we check the next day, all right? If its temp is higher, and we're done. If its temp is lower, we examine, we see, we check, we obtain the day, the first day in the future that has higher temp than the next day, and compare the current day to that future date. We keep doing this until we find a day that has higher temp than current, or nothing. Along the way, we keep track the number of days each jump accumulates, right? So I think on average, this is 01. ON. I think this is ON on average. But no, this type of thing I'm not really good at. The runtime is very slow, so let's see. It's all right. 1288. Wait a second. 45. I count this as regular, right? All right, we have a solution. Let's check the solution. ON squared, yeah. Let's just check one by one. Monotonic stack. Optimized space. Oh, I can do an O1 space. All right, monotonic stack. Yeah, that's just, I don't have to go through everything, just read this. 74 is larger, I mean today is the first day. 75, I pop. 71, so I push it in, right? I push in, and is that a position? Yes, that's the position. 0, 1, 2, 3 position. 69 is the smaller I push in. And 72 is larger than 69, so I will pop. And I do the arithmetic. I see. It's the same idea. It's the same idea as this. This is just going from front to back. So if our current temperature is higher than the previous one, then, so we guarantee that this array will be decreasing, right? This stack will be decreasing. So any value, if it's higher than the front of the stack, that will be the first value that's higher than the front of the stack. And I push it in and I compare, then the number of days is just the difference, right? And then we just keep popping. So that is more clear, ON, because everyone gets hit once. Let's code this up. Good solution. Monotonic stack. Okay, so monotonic stack from the official solution. All right, so I get stack, and the rest. Stack is going to be this, rest is going to be 0 times n, right? Okay, so 4, stack shall be 0. For T in temperatures, right? If stack minus 1 is smaller than, let me think how the implementation should go. You know what? I don't like it. If not stack, then stack. Oh, we need a index as well. So enumerate, right? Then stack.append it. All right. Elif stack -1. 1 is how about equal? Larger equal, yeah. If it's equal, we still push it in. Larger equal to t. Then we can put these two together. If not stack or is larger than t, we push it in. Else, while, right? Stack and stack. Hold on, shouldn't we do this first? Yeah, we should do this first. Do this first. While stack and stack -1 is smaller than t, right? That's when we happen. Then we say pi, pt, previous and previously, the stack.pop. Now after we pop, we're gonna say res pi will equal to I minus pi. Right? I is current. Current is larger, so pi, not I minus pi. Yes, I minus previous equals this. And that should be it, right? We'll record the result, and we keep going. We pop, we keep going. Once we're done, we always push it in. Because either the stack is empty or the front is larger. So once we're done, we always do this. And we just need to return res at the end. Okay? Enumerate. There you go. So this is better. Monotonic stack. Okay. Submit this. I think it will be faster. It's the same. Why would it be faster? Both are OM. Alright. What's this? Optimize space. Do we have we don't. So backwards. Oh, isn't that this? Are you saying I can avoid using another position? Oh, because I already record the date. Yeah, I already record the date. Yes, oh, I am so close. So this solution can be further optimized to achieve O1 extra space. Since I already record the number of days to reach the next higher temp, I can compute the next higher temp's index. This means I do not have to maintain a separate list for it. Oh yeah, so, oh yeah, we're so close. We don't need this, right? So we don't need this. Let's do this. Temp equals this, while j, temp plus equal to this, and j equals to plus equal to res j. And then that's it. Oh, wow. Oh, shoot. Did you increment? I did. I think it's because let's see. J equals I plus 1, right? And then we say, well, j is larger or equal to 0. That's because, j is always larger or equal to 0. I need to change the, so this is smaller, right? And I will go for it. And then res j will become 0, right? So temp will be the same value. J will be the same value. So come back up, j will be the same value. How do I avoid it? We check res j, right? We check res j. So we should say, if res j is 0, which means there's nothing that's larger than it, then we can terminate right there, right? So this shall be res j, while res j, and this when we do this. Okay, a little bit wrong. All right. While res j, so, and this. If res j, because eventually we end up, hold on, eventually, where do we end up? Well, it's like this, right? Res j is equal to 0, because that is just a 0. Now if res j is 0, this one jump out, and res I shall equal to maybe temp plus 1 if, but don't we always end up, so we always keep going until res j becomes 0. Shall be 0, right? I shall be 0 because res j. But how about the other ones? I definitely say res j because eventually everybody gonna go into res j, go into a 1 that has a value 0. So that's what we end up with. Temp. If temp, then we do temp plus 1. If not, that means we have not accumulated anything. So if temp, how? So everything becomes 0. So the next one is larger. While, I cannot do res j, because res j, like here, this one is 0. Res j is 0. Okay, if I don't do res j, then I need to check. We need to check pre and current, right? If I just say, well, j is smaller is not smaller, then I come out. and we're going to do temp plus 1. But temp could be 0 itself. Yeah, temp could be 0 itself. Anyway, this one, check the next. It's smaller than me. We check its value. If temper J is smaller, right? If J is smaller, then go to J, and now I'll find out the next one, right? But I'll first check its. No, I should not check rest J. Rest J should not be checked. We'll have to. Wait, hold on. Do we check rest J? What does rest J mean? It's the next one that's bigger than me. Yes, I should. If this has something, then we have a hope. If rest J is 0, then there's no hope. Then we should jump out. So I do think this part is right. It's just how do we handle this, right? So when it comes out, we have a temp, right? We have a temp. What do we do with a temp? If we need to know if this one is larger than, right? Larger than just temp plus 1. That's done. If it's equal to, then I will say temp, then I'll check rest J. And rest J is 0. So this will break, right? Oh, let me think. Let me think. So we keep going, we will always end up at J. What is J? J is the last value that will end up. So we just do check the last value and me, right? Because I'll always go to the last value and jump out. Ah, yes, I just need to check this. I check this. I say if J is larger than me. There we go. That's the one. That's it. So this is O1. This is O1 extra space. O1 extra space. And it didn't seem to be any faster, but that's O1 extra space. So the implementation. Current temp equals this. And we keep track of the hottest. And if the current temp is larger than hottest, then hottest equals to current temp. We'll continue. If not, we have a day. Then temperature is current day plus day. While it's smaller, we answer plus equal to this. We increment the day. So we go back, right? So we say the current, so this is actually the next temperature, right? If the next temperature is larger, then it's going to be day. If the next temperature is going to be still smaller than me, then we're going to add that number of days to it and check again. Right? And eventually we're going to jump out. Yeah, it's the same idea, but implemented a bit differently. I mean, we implement differently because this one was modified from the previous attempt. I mean, which is the same, right? So this is the same. I say if the next temperature is smaller than the current temperature, right? Then I need to find out the highest temperature, the temperature higher than that. So that's the next. This basically is days, right? That's the next day, and then this will be the accumulated days. Yeah, I think call it days will be an easier, better one. I'm gonna call it days. Oh shoot! To do this days, right? So days and days, and now we just increment the days, and now we find the next position. So this is the next position. Now the good part of this is they use index and day are combined together. Here, index and days are different. And the days will be the delta. But that's fine. So days and increment. Look at this. Days and the j are exactly the same. We're doing the same thing. Did you see that? Right? Did you see that? So we don't need days. Right? We don't need days. I just start with j. And it's j plus equal to. So I just j. J is the index, right? Yeah, and j minus I. And we have to keep doing this because eventually rest j will be 0 coming out. Now, but we don't know, so that's the last day we stop at, right? But we don't know the last day we stop at because we have reached the end, or we have found something bigger than me, so we need to do another check. So that's like another check. How we say this equals this if, I mean, if you want to be cheeky, we can actually do, we can do this times this, right? We can like do this. I'll pass as well. We can save another variable, right? We save another variable. Yeah, we just realized that they're the same. All right, that's it. We don't need to go through the discussion. We know. All right, let's roll another one. Let's roll another one. It's going to be another SQL because we are on a row of SQL. I think we can go to the third page. Consecutive numbers. Yeah, I think that's the. Is that SQL? Don't remember. Have I checked this one yesterday? Yeah, it is SQL. All right, SQL it is. Write a query to find all numbers that appear at least 3 times consecutively. Holy guacamole, consecutively. Return the result table in any order. Ooh. Consecutively. Oh. How do I do that? Well, we have ID. We do have ID. Okay, how about this strategy? We will select unique values out. Okay, that's the first level. And then we're going to select all the rows with the same value. Okay, and then we are going to select what I think is I'll select, right, and I have the ID, and I say I'm going to select where count no, where what? Where the ID is smaller or equal to the current ID plus 2. And then we do a count of that. And if the count is equal to 3, then that value has 3 consecutive. That means, so if say the current ID is 1, and I want an ID smaller or equal to 3. And if there are 3 values with ID smaller or equal to 3 and starting from 1, yeah, it's like from 1 to 3, right? If I have 3, that means that is the one. What if I have like 4 ones? I might be just select unique again. How do we achieve that? Well, we select unique. Okay, so it says select unique. This from score. That's gonna give us 1 and 2, right? Select unique. This where. That's gonna be in the where clause. Okay, is that gonna be in the where clause? Select number. Where something something something. I'm gonna be like count is going to be uh, not count ID where this oh select number from no, it could be from not where but from. I'm going to select number. So from is where the magic we're going to do. How do we do the magic? Select distinct. No. Select distinct number. And then So I have the distinct number, and I say select I say select ID from the table where number is equal to the distinct number. So this one gives us all the ID. Then I select each ID from this. That is an inner join. Right, so we just select ID from the table itself, inner join itself, where number is equal to. No. It's just select the ID from the table, which is called logs, where num is equal to the distinct num. Now we have the ID, every single ID, right? I'll select this ID. We have the ID. Then what? And I want to select a count, right? No, not select count. Wait, it is select a count. We're gonna select an count. Select ID from this. Then we're gonna select. So we have each ID. So this one will be all the ID indices. Then we're going to select hold on, I'm gonna select ID from this, from logs, right? So now we're talking about we have ID and num. So ID is gonna be 1, 2, 3, 5. Num is just 1, 1, 1, 1, 1. Right? We don't need it. We just need ID. So I need to say select ID and count. Right? Having the count. No, where. Select ID. Where no. How about we just select the ID? We don't do count here. So we select the ID. So this one is the ID. So we have the ID out. Now we're gonna select ID, right, from this, then having, select ID, then having no, not having, where current ID is, let's say, smaller or equal to the previous ID plus 2, and current ID is equal to, larger equal to the previous ID. So current ID is larger or equal to the previous ID. So like for each ID to select, Isn't this in reverse? Yeah, I think I got the sequence wrong. Each ID I select, right? Each ID I select. Okay, so if I say select ID from those unique, from that specific value, right? Select ID from these specific values. Now for each ID from this, right, then we'll select it if the number of counts, right? So that's going to be a where select count star from that unique thing from that T, select count from T where ID count from an ID is larger equal to ID and ID smaller equal to ID plus 2 from where having this count equal to 3. Select ID from, select ID count, so I have ID and count from that unique thing where ID is larger than the previous ID. I need some insight from yesterday. Let's open yesterday. I mean, it's just for SQL purpose. I kind of just, so I say select this from this, and I can add another query in here. Select this from this, and every inside I can refer to outside. So select this from, select this, and because I need the current ID, right? So I have to say select ID and something, right? Select ID and something from the thing as a t, which is the current value, right? Which is the unique thing, right? The unique thing. Then from this table, I get the ID of the duplicates of the value of the duplicates value. So I get the ID. This ID is useful. So I say select this ID and something else. And this something else will give me a count. Okay? So when I select count from this unique place, by having count equals 3, I don't have to select this count. I just need to select the number. Okay? I select a number where the count is 3. So eventually this one will give me ID and a number. And eventually I just need to select the number. Okay? So I can just say on the most outside, right? On the most outside, I can say I will select distinct num from logs, right? That's the distinct num from logs. And then I select distinct num and I'll select ID. I'll select distinct num and I'll select another thing is ID and select distinct num. So each num is a distinct number. And now I'll select the ID, all right? And the ID is the ID of each distinct num. And then, so I select this and select ID and select another thing. Select the, I don't have to select the number again. I can just select the count, right? I can just select the count, right? Having this count equal to 3. Now I just select ID and I select count having the 3. So if it's not, then I don't select the count. Then it'll be nothing. How about if no? How about if no? Where do we use if no? 177? Yeah. We can say select if no. Select distinct salary from something. Oh, that's dense rank. If no. Select if no, and I just select this thing. Limit. So this is, we're trying to see if it's good, and we select it. If it's not, we select no. So it's the same thing. So we say select ID and if no, right? Select if no. Select having this or no, and then we're gonna select ID and select if no. And on the outside, we're gonna select distinct, this, and another level select if no. That is very convoluted. Like very, very convoluted. I'm not sure. I'm gonna try it, but man, this is tough. The heck? The heck of this? I shouldn't say it's. Well, it's more of just I'm not used to it. I'm not used to it. Yeah, let's do this one. 180. 180. Talking about getting out of your comfort zone. This is very much outside my comfort zone. I cannot express how much outside the comfort zone this is. All right. So the most inner one I'm thinking is going to be select count star as C, right? Count star from, also select this from T. This is going to be a table, distinct table, right? Where oh, we'll have another one. Select. Oh gosh. I'm selecting from the same table. I'm doing the same table. How about I select ID and num, right? I select ID and num, and now I have the ID from the outside table. And then I'm going to select count this as C from, this is going to be another table, okay? So this is going to be select select star from select star from logs where logs L2 as from logs L2 where L2 dot num or equal to L1 dot num. Okay, so L2 dot num will equal to L1 dot num. So I select all of them, and from this, I'll call it T. So I count this from T where T dot ID is larger or equal to L1 dot ID and T dot ID is smaller or equal to L1 dot ID plus 2. Okay? So when I count inside how many there are, select this from where. So that's the count. So we got the count. So this count is given the L1 ID, how many values of the same num with their ID from L1 ID to L1 ID plus 2, where this having C equal to 3. Right? So we select count this having C equal to 3. Right? So if nothing, it's going to be null, I suppose. I suppose it's going to be null. but not sure. But I have another layer, which is the L1. So it's a select ID. I'll select star from select select I think just select this, right? Can we just select this? Select this. From logs L1. Alright, this is like the very first, let's see, I'm not sure. Looks shabby. Okay, what do we have? Man, I need to echo this? This is a string. Nope. Headers, we're having values. Maybe 3. No. We might be onto something. Alright, so if I select this as how about select num? Hold up. Let's go back. So this one produced 3, right? You see, we actually very close. This one produced 3. So this count produced 3. Though we just need to use if null, right? We need to use if null. So if it's null, then we return. So I'm going to select where select count. How do we avoid a null? Maybe, can I do this as a where clause? I don't know, select num from this where that would be very weird. I don't know. This probably does not. Oh, I think I got it. I just need to change this as consecutive nums. Wow, let's go through this again. So I select num, right, from logs. So what type of num I want. So this is the condition. The where is the condition, because this one will give us a null or something, right? So for each num, I'm going to then I don't need, I can just use, that's fine. That's like basically for each num that comes out, I'm going to say, we're going to select count as C, right? And then from. So if it's basically this for each row, right? For each row, I'm going to select this. So for each row, when it goes in here, so L1.num is the first row, and this one will from another table. That's from everything. Lost L2 from L2, where L2.num is equal, so we get the same value, right? Say same ones, all ones, and all the IDs. So I'm going to select count of that. So this thing we'll name it to T, and T will have an ID. But I can actually just say ID, right? But it's fine. And then where T.ID is largely equal to L1, that ID, and T is smaller than this plus 2, where count is equal to 3. So this one, count, will either become 3 or become null. And then for each row, this will give me a thing. But I just realized something. The test case. So what we can do is, let's add another one. Like, oh, perfect. Let's see, this one. I might select multiple. I have 1, 1, 1. This therefore, and select distinct. All right. So at the end, we need to turn that into distinct. Submit. Oh yes. Oh yes. Very slow though, but we got it. Oh my goodness. Talking about being so happy. Wow, this is the very first complex SQL query I have written. My God. The idea is to count, right? Not consecutive. To count the number of rows for a given number of rows for a given number with ID restriction from that number's ID to that number's ID plus 2. If that count is equal to 3, we have a number that is repeating consecutively for 3 times. Yeah, so that is my idea. Oh, let's go. Let's check. Oh, it has solution. This one has solution. Oh. Means the ID of the nums are next to each other. Since this problem asks for the numbers appearing at least 3 times, 3 aliases for this table log, and then check where 3 consecutive numbers are all the same. Select star from, oh my goodness, you can do that? I don't know, never know that. So basically we get 3 tables, no, we got 1 table, but alias is 3 times, where this equals this equals this. Then we can select any number. Ah. Analytical functions. Select distinct from. Select number. Lead number over ID as lead. Lag number over as lag from const test T, where num equals lead and num equals lag. Yeah, of course. That's not the idea. It is consecutive. Oh, ID. Ah, that is true. You redo the row, you redo the index. Wow. All SQL gurus here. Damn. Okay, let's see this one. Select the synonym as this from logs where ID plus 1 num in and ID plus 2 num in. That's the same idea. That's fine. Trust me. That's the same idea as the original solution. Okay, so this thing, the lag. What is lag? Row number over group by. Oh my god. Anyway, I think I was just gonna go check one more thing, the lag and lead. What's lag? What's MySQL lag? To look back a number of rows and access data of that row from the current row. Lag over something. I want examples. Oh. Production sales. Production line, year, round, order, inner join products, group by product line, and order year. Okay. So select product line over here, lag order value 1 over partition by order line, order by order year, previous year order value, previous year order value. Huh. Let's read again. To look back a number of rows and access data of that row from the current row. Returns the value of the expression from the row that precedes the current row by offset number of rows. within its partition of result set. Back from the current row, the number of rows. So when I'm here, right, I want to see 1 or 4. It's lagging. Okay, so I'm gonna go order value. So for each row, I'm gonna look 1 in the back within partition and order by order year. So this one will obtain the previous year order. This one will get this. Okay, that's lag. I'm pretty sure lead means the other way around. Right? Lead means the other way around. Is this one? No. I think it's in the solution. Somebody posted a lead and lag. So a distinct number and a select number and a lead number and a lag number. What's const test? Huh? Over order by ID. So we order by ID. So lead. What if it's just one value? The offset is optional, right? Back from the current row. Must be 0 or a little positive. If offset is 0, if we don't specify, then the lag function uses 1 by default. So I don't specify, so it uses 1, which is going back, right? I'm going to select num, and this must be lead. This must be lag. From what's const test? MySQL const test. I don't know what that is. What does that mean, const test? Oh, that's just a name. That's just a name. That's just a name. No. No. T is the name. T is the name. Oh, this is a log. That's log. That's log. Let's read this one. Select distinct. And I select this. So lead, which is I assume lead is the next one. If the next one and over and order by ID. Order by ID as lead. So order by I. So I am looking through the num column, right? I'm looking over the num column, and I have an order by ID. So if I order by ID, do I order by ID first? Right, this should be order by ID first. So select any number I order by ID, and then I look at my current number when I go lead, which is the next one. And I want to go one above it, the previous one. And then when I come out, so that's going to be 3, right? So I'm going to select the number. If this equals this, I think I understand. I think I understand this. So lag, I'll definitely need to use a lead. I think lead means the next one. If I'm not mistaken. Forward a number of rows. So this one will look forward. Forward. Okay. And we'll select this, right? And a lead. So for each order date, I will partition by customer number. I will order by order date, right? And then I know where the order date of the current row is, and I will go one further. To each partition to get a next order date. So this one is using lag and lead. So select, again, distinct, right? T.num as consecutive nums from something, right? From something as T, where T.num equal to T.lead equal to T.end, T.num equal to T.lag. So now we're going to create, select, something, num, right? So select num and lead. So lead num over, don't partition, but let's just be more explicit. Lead num1 over order by ID as lead, the same thing. Lag from logs. Uh-oh. Select this. Maybe same thing as last time. Nope. Hmm. Ah. What's the difference? Select distinct from select num lead over order by ID lag from logs t where t dot num. Oh, equal. Jeez. Come on, man. Come on. Equal. I think they raise a good question, right? So what if I have, let's say, one, I said 1, 2, 3, 4. How about 1, 3, 5, 6, 7, like that. This one shall still work. But the expected is nothing, right? So the expected answer is not good. Is not good. But the idea, I take it. I take the idea, we got 3, and then we just need the L1 to be L2 minus 1, L2 is L3 minus 1, and L1 number equals to this, and this equals to this. But I like this one, so this, I'm gonna upvote this, but I mean upvote this. I'm pretty sure I don't need to use, I don't think lead and lag are special characters. Oh, they are. Wow. They are special characters. Okay, so I'm gonna copy. Inspired by this. So this solution is better than the official one because it also handles the case where the index, the ID values have gaps. The ID values of but consecutive appearance. I think that already eliminated possibilities. 3 consecutive times. Yeah. The ID values have gaps. Handles where the 3 consecutive numbers do not have consecutive ID values. That is, right, the ID values. That is, their ID values have gaps. There we go. Alright, let's submit this. Pretty sure this one will be faster than the earlier attempt. Oh yeah, ooh, speed. But anyway, I did it myself, so I'm proud. Alright, that'll be it for today. I'll see you guys tomorrow. Adios.